Okay, guys. So, couple of days back, what we discussed basically, we discussed about Python, advantage of Python compared to other languages, and we also discussed about package. Package essentially a combination of our, group of what group of
What cell?
what is package? What is package?
Group of modules.
Correct. Group of modules. And a module is basically a group of function. So Python as being Python is open source language. Our language there has been lot of open source packages people are building, and what we need to is basically we need to install the package and refer the package and module within the package name dot module dot function. That's how we instantaneous package, we'll call the package, we use the package. So we discussed about NumPy. NumPy is essentially called as numerical Python, which works with lists and arrays. Then we have discussed about pandas. Pandas is essentially more than two-dimensional data, and it's called data frame. And we also discussed about the difference between data frame and list. Data frame essentially try to store the multiple types of data. So whenever you read any data by using CSV, it will store as the data types. And we also seen how to select the variables, how to go to some locations. That's what we have done. Today, what we are trying to do, we are doing today how to understand the data using descriptive statistics and visualizations. And if time permits, we'll also see the how to prepare data for analysis. And tomorrow we'll do the small project, and next week I will explain the big project. By that we are done. So today what we are doing, we are trying to do understanding data using descriptive statistics. So we have discussed descriptive statistics long time ago. Descriptive statistics essentially try to express the complete distribution through a single value. We have discussed mean, mode, median, and when it comes to the measures of dispersion, we try to find the location, how disperse the values from the central value. That's where we discuss median, standard deviation, variance, interquartile range such that, and we also discuss the shape of the distribution as skewness and height of the distribution as in the kurtosis. Basically height of the distribution will try to give how many, is there any outliers or not. Shape of the distribution will give where the data is shaped. So all this we'll see. Now I told you that I keep on telling you that machine learning is not code, it's a thought. So code is very simple. So let's do it, but we have to do it. So what we are trying to do, first we are importing pandas, because to same data we are reading same like Titan data. So let's see how to find the descriptive statistics from the data. So I think I didn't send the codes today. I will send all the 4 codes. You try it. So I'm importing pandas as PD, which is an alias. That's what I'm doing. And then I am reading data. To read the data, we have a function called read underscore CSV in the pandas. That's what I am instantaneously, I am calling that function using pd dot read underscore CSV and data dot CSV. I'm reading the data. And we have seen how to see the shape, last week shape, all those variables. And this is what the data. And if you want to see the shape of the data, you just need to shape of the df dot shape. So 891 and 12. So it has 891 respondents and 12. Now we need to understand the descriptive statistics. So we know what is the descriptive statistics, we already know. So in order to do the descriptive statistics in Python, we have a function called describe. Okay. So when I say the describe, what it does is it basically, so there will be two levels of doing it. One is doing at the data frame level. What is our data frame here? DF. So if you want to do, if you don't specify any variable and if you call any function, then that function will work at the data frame level. If you mention any of the variable within the data frame, and then the function works with that particular variable level. So here what I am saying, this describe is basically at the data frame level. So it basically try to explain the complete description of the data set. So when I say, if I want to understand the key statistical measures like mean, so median, standard deviation, minimum 25th range, 15th, 70, because 25th quantile, 50, 75 quantile is very important to identify the missing, outlier. So describe is basically a function which can give a lot of statistics associated with the data frame. So that's what we will do. If I say df dot describe, So what it does, it works with the, so we know, we last week we say if you want to see the columns, what are the columns there in the df, we say df dot, if I want to see the variable name df dot columns, if I say df dot columns, it will give all the variable. So now if I say df dot describe for all the variables in the this font data frame, it will give the descriptive statistics. Understand? So that's what it is doing. If I say df dot describe, so then it will give for every variable how many variables are there, count, and you see there are 740 means there are some missing values are there, and mean value, what is the mean for each variable, standard deviation, minimum value, maximum value, 25th percentile. This is what describe will give. So this is doing it in what level? Data frame level. And last week we discussed, if you want to access any variable at a data frame level, what you need to say? You need to say this bracket of years. So if I wanted to see only the distribution for, I wanted to see, because it is giving only summary statistics. Whereas if I want to see any distribution, if I want to refer only one variable, what you need to say? Df of this bracket age dot underscore value counts. That's why you need to go and read a lot of pandas. Pandas has a lot of function. E value underscore counts basically will give the distribution. So for which, if I won't specify anything, it will give for all. Then if I want to look it for only one variable, this is how I should refer the variable in the data frame. So df of this column age and value counts, then it will give this thing. So you can see the age distribution. So instead of age, if you want to see for fair, what you need to say now? Let's include. If I want to see the distribution for fair, what should I do? df of, as soon as if you say and say tab, it will give, sorry, what is that variable we have? Fair, no? Sorry, what happened? So df of, what is the variable you want to see? What variable distribution you want to see? Let's copy that and paste it. So FARE fair. So I want to see the distribution for. So I will just refer any variable how this bracket of FARE. Whatever. RE dot value underscore. So what it does is counts. It will counts for the fair. That's how we'll see. But counts is not important. See, if you want to see the info for the class, the class is basically P class 1, 2, 3. How many classes we have? 3 classes. So this is what value want to call. If you want to find the percentages, so shape of 0 means what? Number of rows. So what we are trying to do basically, each count, if you divide it by the total number of cases, then what we will get? Percentages. That's what we are doing here. So if you want to find the percentage for P class, because as being categorical variable, you need to see the class. So how do you calculate the P class dot value counts will give the counts number. But if you want to see the percentage, how do you see the percentage? Basically percentage you will see by dividing the number of people. So how do you get the number of people? Df dot shape 0. Shape 0 is rows. So df dot shape 0 means how many rows you have df? That is the total number of cases. So value divided by total number of cases basically will give the percentages. If you run this, you will get the percentages. That's what the percentage. Okay. This is what basically do. And as I told you that sometimes the variable type is very important. So we have like two types of variables, and scale is very important: nominal, ordinal, variable. So all the nominal variables stored as int integer. If you see the type, d type is the integer. All the numerical variable will stored as integer. All the categorical variables saved as object. Even the P class is 1, 2, 3. We need to make this as an object. Actual dummy variable concept is there, which we will discuss later. But any variable, if it come up with like name as alpha, sex, male and female, ticket, any variable starts with letters will store as the object. That's why whenever once you read the data, if you want to see the what are all object variables you have, just you need to write, it will give the all the categorical variable. 1 minute guys, let me close this thing here temporarily. So that's what. Okay. And this is what the objective is. So sometimes if you want to understand what are the different unique categories in the categorical variable, like male, how many categories you have? Male, gender, and male and female. So gender has 2 categories. Tickets, we don't know how many categories are there by seeing data. Cabin, we don't know. If you want to understand the number of levels in the each categories, you just need to say df dot categorical variables. I am saving all the categorical variables as df dot d types of location. If d types equal to object, d type equal to integer means integer variable, object means categorical variable. So this basically will give the number of this thing. So we know name has 891 different names, sex has 2 categories, male and female, ticket has 861 different categories, cabin has 148 MR. So this is how we can see it. Now we are coming into the central tendency. If you want to find the central tendencies, what are the central tendencies? We know mean, median, mode. So any variable, you just take the variable and just run this thing. Age equal to df of s. I'm just assigning a df of s to s and try to calculate mean for age, median, and mode also. And just I'm printing. That's all. If I do, what is the problem here? Small p. So this is what. See, for years, I think we are getting mean as 29, median as 28, and mode as 24. So most repeated value is the mode as the 24. Even if you see the up also, we can understand why my mouse is not going up here. Right? If you go and see age, we have I think 19 is like 24 is basically repeated 30 times. That's why it come as mode. If you see also highest number of repeat. So that's what mean, median, and mode. So this is how to basically measures of central tendencies, and that's what only describe will give mean, median, mode. If you want to see that same thing we are doing it, right? So similarly, if you want to find the minimum, what is the minimum value of age, maximum value also we can calculate. These are all basic fingertips. Then we can also calculate the range. When it comes to the measures of dispersions, the range is first one, range. Then variance basically. Then actually variance is basically units. That's why we need to see the standard deviation. That's what we will go for the standard deviation. See the variance has units effect. See 211. Even maximum is 100. But why? It has units effect. When you are calculating the variance, we have the formula xi minus x bar whole square. The units will be getting doubled. In order to pull back, we do the standard deviation. Okay. And similarly, you can calculate any percentile, any quantile. So this is what generally people will calculate the fifth quantile, and this is what very important. When we are working with the Bosc and Whisker plot, we basically find interquartile range, and based on the interquartile range, we will basically find the box plot. Now that's where we are doing quarter 3, whatever any quarter you can. This is 75th quarter, that is quarter 3. This is basically quarter 1, 25th quarter. Then interquartile range is equal to interquartile range is quarter 3 minus quarter 1. Then how we can calculate the whiskers? Quarter 3 plus 1.5 into interquartile range will give the upper limit. Quarter 3 minus 1.5 into lower quartile will give the lower. Then we will calculate outliers. Hope you remember. So that's where it will be useful, interquartile range. And this is what very important. If you want to find the skewness, basically the skew is the function. This is the skewness. If you want to find the kurtosis is the function. So that's what I am telling you. Code is very simple. So this is what you basically able to understand data using central tendencies. I also run one more program. This is same thing. So stats2 underscore ds, we have just two measures, object and measures. If you want to understand the statistics, what you do, basically you read the data. This is how you read the data, and we have only two values. Now can you find the measure? Print mean, same df of, we have only two variables. You want the measure. So what you are trying to do, you can do all in one cell also. Print mean comma data of measure dot mean, median, mode, skewness, and kurtosis. All these are the 5 values people will use. Generally this is how people will use. So this is the function, very simple. Then yeah, variance is basically where standard deviation is standard deviation, and standard error is also very important. And as I told you, the describe will give the statistics measure for all those things. So that's what I mean. This is very simple. I think even covariance also you can calculate. Data dot covariance is basically covariance. It will give the. Oh, I have to read the data. Sorry. So now we have both input and output in this data. So similarly, if you want to calculate the covariance correlation, also we can calculate. Simple. Here I have input and output. If I want to see the what is the covariance between input and output, yes, this is the covariance, and this is the correlation. Just data dot correlation. I think in the visualization we'll also see how to visualize the correlation. Okay. As I told you, that code is very simple. Don't worry about code. And this is what people will, once you read the data, I think these are the default things we need to see. You need to understand the data using descriptive statistics. So describe is very popularly used command. Then value underscore count will give the distribution. If you want to get the percentages, you just need to divide by the number of cases. That's why you take shake of 0. Then skewness and kurtosis are also very useful. Interquartile range, you just use the quantile function. And covariance is covariance, correlation is for correlation. What is the difference between covariance and correlation? Guys, what is the difference between covariance and correlation?